Applications of homogeneity. Basically, there are many applications of homogeneity which we have to discuss. Number one, finding missing finding missing powers in an equation. So we can use homogeneity to find missing powers in an equation. For example, example 1, time period time period of a simple pendulum depends on its length and acceleration due to gravity as t is equal to k times L power m g power n. So time period of a simple pendulum depends on the length of the simple pendulum and acceleration due to gravity according to this relation. Now use base units to find m and n. Use base units to find m and n. For example, now the relation is t is equal to m n power, and one more thing, one thing is missing. Given that k is a constant with no unit. Given that k is a constant with no unit. So to solve this, unit of time period is second. K has no unit. If something has no unit, it is substituted with 1. Unit of length is meter and its power is g power n. It was L power n g power n. Length meter, power m. G is meter second minus 2 power. And now let's simplify this. Second power 1 is equal to meter power m, meter power n, and second power minus 2n. Now the problem is on the right hand side we have 2 base units, and on the left hand side we have no meter. Second is present. So if you get a situation in which you get a base unit on the right hand side that is missing on the left hand side, then you will put it on the left hand side as meter power 0. Now if you solve it, equate the bases on the two sides. For example, meter power 0 is equal to meter power m, which will lead us towards, one second, meter power was m plus n. So however on the left side meter is missing. On the right hand side, meter power must be base is same, power will be added. On the left hand side, it is second power 1. Here it is second power minus 2n. So if we simplify it, it will become, since meter is on the right hand side while on the left hand side meter is missing, so you need to put meter on the left hand side, meter power m plus n, second power 1, and meter power m plus n, second power minus 2n. Now this will become, since there is no meter on the left hand side, so replace it with meter power 0. If some base is present on the right hand side and it's not there on the left hand side, it is to be replaced with power 0. So meter power 0, second power 1. Now if we equate the bases, so meter is not on the left hand side, so we put meter 0 there. Now we equate the same bases. Meter power 0 is equal to meter power m plus n, which will lead us to m plus n is equal to 0 and negative 2n if we equate second. Power 1 is equal to second power minus 2n. This will lead us towards second power 1 is equal to second power minus 2n. This will lead us to 1 is equal to minus 2n. After solving it, n will become minus 1 by 2. So n is minus 1 by 2. If we substitute this value of n, m plus minus 1 by 2 is 0. And this will give m is equal to 1 by 2. So m is 1 by 2. N is minus 1 by 2. So we can write it as T is equal to K times L power 1 by 2 and G power minus 1 by 2. So this is one example of finding powers in a relation.